See, another interesting part of this topic is transpose and its properties. What do you mean by transpose? Let me give an example. A simple column matrix. 1, 2, 3. This is the matrix now. So what is A11 here? 1. A12, A21. Sorry, we don't have second column only, right? 21 is 2. The third row, first column, what we have is 3. Now, if I interchange them in such a way that the I and J must be interchanged. So, but the value will be same. A11, as there is no change, the values are same. The one remains as it is. A21 will become A12. That is 2. The value remains same, but the order changes. Position changes. A13, 3. Now, if you substitute back in the matrix, it is actually having only one row. This has 3 rows, 1 column, that is 3 by 1, but this will give you 1 by 3, right? So what is our matrix? 1, 2, 3. This is transpose of the given matrix. So what do you understand? What do you understand? One more example you want? Yes. 1, 2, 3, 4. It's a square matrix now of the order 2 cross 2. Okay. So what is A11? 1. A12? 2. A21? 3. A22 is 4. Now what are we going to do? Apply the same concept. If I and J are equal, the value will not change. Now A12 will become A21, which is 2. Right? Now A21 will become A12, which is 1, and A22 will remain as 4. Now, if you substitute back, we get a matrix which is having 1, 2, 3, 4. Let this be B, then this is B transpose. Okay, so what do you understand? A transpose of a matrix is obtained by interchanging the row and a column. Okay, if it is a square matrix, the diagonal element remains unchanged. This is not a square matrix, so there is no diagonal element. So a column matrix became a row matrix when it is the transpose, whereas a square matrix remains as a square matrix. Only the identity, that is the diagonal elements, will remain in the same place, whereas 2, 3 interchanged here, right? So what is the meaning of transpose then? Let's see the definition. With example, we understood what is transpose and how do we theoretically say transpose of a matrix. Let's see. So let me remove this, erase this. Yes. Let me read this clearly and loudly. The transpose of a matrix is obtained by interchanging the rows and of a matrix A to the columns of the matrix A. And interchanging means what? Rows to the columns, columns to the row. Two-way, right? When you interchange, that will become like this. So this example here, 137, first row 137, second row 248, third row 0 minus 2 6. That became first column, second column, third column, right? Whereas column wise 120, 342, 780, that will become row wise now 120, 34 minus 2, 786. That means what is transpose of a matrix? Transpose of a matrix is obtained by interchanging the corresponding rows into columns and columns into rows. Okay, right? It's a very simple approach. Let me give you one more example. Tell me. It's not a square matrix. What is the order of this matrix? Order of this matrix is 3 cross 2. Now when you transpose this, you will get what? You should get what? 2 cross 3. So 1, 2, I'll write here. So you don't have to use all those steps now. This first row becomes first column, second row becomes second column, and third row becomes third column. Simple. So this is our transpose of this matrix. Right? So simple as that. So is it difficult concept? No. See, here we have multiple concepts and all of them are very elementary. We don't have any tough syllabus like we used to have before COVID. Elementary operations matrix has been removed. So you should not be cribbing this topic is difficult anymore, because that's the most complex thing for people to understand and to remember. That is completely removed from this topic. That is elementary operations are matrices. Okay, so we don't have to use that. We don't have to even, I mean, from the point of view of the exam, we don't have to learn them. But if it is something interesting for you, you can always learn, but don't deviate from the syllabus right now. Finish the exam, and then you can search the elementary operations and matrices later. Okay, right? Let me remove this now. Properties of transpose of a matrix. You can make a note of this in your revision notes, like a summary. What is it? If you take a transpose twice, you will get the same matrix again. Double transpose. You can use this dash symbol or you can use the T symbol. Both are same. Transpose of a transpose will give you the same thing. For example, see 1, 2, 3. This is the matrix I'm giving you. What is this transpose? Its transpose is 1, 2, 3. Now I want the transpose of the transpose again. What will I get? I'll again get end up with the given matrix itself. Isn't it equal to A? Yes. That's what it says. A double transpose, a transpose of a transpose will give you the same matrix. That's the first one. Fine? Clear? Yes. What about second one? If you have a matrix multiplied with the scalar and then you take a transpose, you can take the scalar outside and you take the transpose of the matrix and multiply. It will be same thing. That means you can take the scalar outside and multiply that with the transpose. It will give you the same answer. Okay. Third rule is very interesting. When you take the transpose of the sum of a matrix, that should be equal to individual matrices added after getting the transpose. So this is a very interesting one. The last one is also an interesting one. If you take a product of two matrices and take it transpose, it must be equal to product of the individual transpose in the reverse order. This is a new thing. Maybe you may not be able to remember it until you try to write down and see some proofs. Okay, so you can prove, you can take two random matrices, take the product, take its transpose, and individually you take the transpose and then multiply in the reverse order and verify they will be equal, because that's a rule. It's been framed as a rule. That means these rules, without any terms and condition, without any exceptions, this will be always true. If there is an exception, we would have mentioned that. As there is no exception, this rule has to be universally true in all the cases, right? Let me repeat these properties again. One is when you take the transpose of a transpose, you get the individual matrix which is given, original matrix. And when you take a transpose of a matrix multiplied with a scalar, you can take the scalar outside and multiply the same transpose of a matrix, you'll get the same result. And transpose is also now distributive. Can I tell like that? Yes, there's no doubt in that. When you take the transpose of a sum of two matrix, it will be equal to transpose of the individual matrix added together, right? The last one is transpose of a product of a matrix will be equal to product of the transpose of the matrix in the reverse order. Remember the words I'm saying. If you understand these words, you will not forget this. What I'm saying is a product of a transpose of a product is equal to product of the transpose in the reverse order. Transpose of a product is equal to product of the transpose in the reverse order. That's very important. The reverse order, not in the same order, but in the reverse order. Why, how, all that is really, if you are curious enough, it's very interesting. You can discover yourself a lot of other concepts. But right now, let's stick to the syllabus. Okay, you can always research why. There is always a curiosity that will lead us to more knowledge. Okay, that you can do that later. It's very interesting to explain why. I'm so tempted to tell this, but we are not having the time, freedom of time, because it's a revision class, right? So we will see if we can put some interesting videos about why these concepts are like this, and we'll come up with that. It might help us and help you guys in cracking some competitive exams, Olympiads and all. So let's see if that is possible in future. Right now, let's stick to the exam point of view. Okay. Yes. There are 7 questions. Let's solve all of them. Find the transpose of this. It's a very simple question. Matrix given is 7, -2, -4, 8. This is what is the order of this matrix? Can anyone tell me order of this matrix? Yes, 2 by 2. Its transpose will also have 2 by 2 because it's a square matrix. What is the specialty of a square matrix? In a square matrix, when you take the transpose, the diagonal elements remain same, but 2 will come here, 8 will remain here only, 4 will go here. This is the transpose of the given matrix. You have a doubt? You want to check the answer? Let's see. See, 7 -2 -4, 8. Next question. If it's an assertion reasoning, okay, if the question is not visible, let me zoom it out. Assertion reasoning. What is this saying? A transpose of a matrix. What is this matrix? X. Let me write it. X. X is 2, 5. That is 25, and then 1. It's what kind of matrix it is? It's a column matrix, is it? That's a question, right? It's an assertion. Is it as this is not a column matrix? They're telling transpose of this matrix is column matrix. So what matrix is this? This is row matrix. So what is the order of this matrix? 1, 2. And what will be the transpose will have? It will have 2, 1. That is 25 and 1. Is it a column matrix? Yes, it is a column matrix. That means the assertion is true. As the assertion is true, I can rule out option D. Option D says assertion is false, whereas all the other options says assertion is true. Now, let's look at the assertion is true, right? Let's look at the reasoning. The reason says the transpose of a matrix M cross N forms a matrix of the order, same order. So M cross N transpose will not give you M cross N, it will give you N cross M. That means what? Reason is false. How many of the options says reason is false? The second one, that is option C, says reason is false, whereas option A says both are correct. Option B says both are correct. So what is the answer then? Answer is option C, that is assertion is true, reason is false. See, you can always eliminate the wrong options when you think it, when you get to know clearly it is wrong. But this needs a lot of practice and very good with basics. You should be good with basics. Okay, so I eliminated the wrong options to lead to the right options because assertion and reasoning questions are always confusing. So the best trick is to remove the wrong options when you know it is wrong, so that you will never come back to that and get confused, right? Yes. Let's go to the next question. Another assertion reasoning. So can you spend some time in this question? And let me zoom this question. Yes. Please read this and tell me the answer. Option A, B, C, or D. I'll give you 15 seconds. Your time starts now. I will not even read. I'm expecting answer from your end. So assertion is, let me read now, A dash or A transpose is a transpose of a matrix A. Is it true? That's a method, that's a symbol we use to show the transpose. That means yes, assertion is true. As assertion is true, what we can eliminate is option D can be again eliminated. Okay, assertion is true. What about the reasoning? Transpose of a matrix is obtained by interchanging the rows of a matrix to the columns. Isn't it correct? Yes. So assertion is also true. Reasoning is also true. That means the answer is also, is it a right explanation to this? Yes. That's also very important, right? A transpose is a transpose of a matrix A, and transpose of a matrix A is obtained by interchanging the columns. It is talking about this matrix only. So reason is a right explanation for the given assertion. That means the answer is what? Option A. A and R both are correct, and R is the right explanation, a correct explanation for A. Right? So let's go to the next one. Now, how many of you are feeling assertion reasoning is very easy after solving these two questions? Yes, please use this trick. It will always work, but I only want you to be very good with the basics. If you want to use this trick, you should know what is right, what is wrong. Then only you can eliminate the wrong ones. If you are not sure about the wrong ones, you cannot be sure about removing this, right? So be careful. So I want you to be sure about what is wrong and what is right so that you can eliminate the wrong ones, right? So let's go to the next question. Yes. So we are done with this question, right? Yes. If a matrix A is it's a row matrix. Can you see? Yes, it's a row matrix. A is given by 1, yes, 1, 2, and 3. Okay. Then AA dash, where A dash is the transpose of a matrix, we have to now find A dash. So what is A dash or A transpose? 1, 2, 3. Now what we have to do? We have to multiply A with its transpose. So what are we getting? So tell me, what is out of this matrix? 1 cross 3. What is out of this matrix? 3 cross 1. So when you multiply 1 cross 3 and 3 cross 3, it should give you what order? 1 cross 1. Now can you eliminate the wrong options? Which of them are not 1 cross 1? Option A is not at all a matrix, so it's wrong. It's just a number. Option B is 3 cross 3, so which is not correct. Option C is also 3 cross 3, which is not correct. Then what are we left with? We are left with only D. If you want to solve these questions faster with less time, and if you know this concept, 1 cross 3 multiplied with 3 cross 1 will give you only 1 cross 1. And luckily, that is fortunately, we have only one option, which is following this order itself, right? That's the answer. You have a doubt? Let's verify. First row, first column, right? So what will you get? 1 into 1 plus 2 into 2 plus 3 into 3. So it's only one element, which is 1 plus 4 plus 9. So 9 plus 5 is 14 inside the bracket because it is a matrix. So product of A and its transpose has become 1 cross 1 because it's a row matrix of the order 1 cross 2, 3 multiplied with the column matrix the order 3 cross 1. Its own transpose, which will give you simply 1 cross 1. Simple? Yes. So this is a very interesting question, right? Let's go quickly to the next question. Right. There is a matrix given, B. Let me write this. So this B value is given 4, 5, minus 8, 6. So what are we going to do? We are going to find out its transpose first. What is the transpose of this? 4, 5, minus 8, 6. Now we're going to multiply this with 3. What is 3B transpose? As is a multiple choice question, the steps are not important, but we have to be careful. 12 minus 24, 15, and then 18. Am I right? Multiplied with 3. Now, this will be multiplied by 2. So what is 2b? 8, 10, minus 16, 12. Now, what are we going to do? We're going to add them in this order. 3b minus 2b. 3b transpose minus 2b. So when you add this 12 minus 8, right, minus 24 minus 10, 15 minus of minus become plus 16, and then 12 minus 18, right? Sorry, this is 18 minus 12. Let me erase this better, which is 18 minus 12 in this order only, right? So minus 24 minus 10, every order is correct. 12 minus 8, 15 minus 16, that is Now the answer is, we have not reached the answer yet. This is 4. This is minus 34. This is 31. This is 6. And we want its transpose only, not this. We want its transpose. So what is its transpose? Its transpose is 4 minus 34 plus 31 plus 6 is the answer. Which option? Which option? By quick observation, the answer is option D.